Hi, this is Jose Luis here at Parametric Camp, and in this video in the series Advanced Development in Grasshopper, what I would like to do is I would like to introduce you to the generation of more complex data types like curves and BReps, and very specifically to the more idiosyncratic patterns that RhinoCommon uses for the generation of those particular more complex data types. And why am I saying this? Well, if you remember from previous lectures, you remember that I was discussing how, in general, Rhino divides simpler data types into using structures. So, for example, structures are used for points, for lines, for vectors, for data types that have very simple numerical representations, like 3 numbers, 4 numbers, a point and 2 vectors, something that can be very easy to represent. However, classes are typically used in RhinoCommon for more complex data types like curves, BReps, meshes, objects that have a lot of information, a lot of functionality, and that are a bit more heavyweight. And this is because when we generate, for example, simpler data types like vectors, you remember that we were using simple constructors where we passed initial information, like the 3 components of the vector, and then we created an instance of that object. That is the same for planes, for lines, for points, and we can see that if we go to the vector 3D structure, the constructor has several overloads that allow us to give it different types of information to create that instance. Unfortunately, or well, I don't know if that's actually, I take that back, the unfortunately. Differently, curves and BReps, because it turns out that they have much more information, we cannot use simple constructors to create curves or to create BReps. If we go to the documentation of the BRep class, for example, we can see that it has 2 constructors, one to create an empty BRep and another with this weird thing called serialization information and streaming context, which we can't even access because it's protected, and I can see it from the icon right here. Whereas the curve class, for example, doesn't even have any constructor available. This one, I cannot even use it because it's also protected. So if that's the case, how can I create curves and BReps? And also, why do I not have constructors? It turns out that I don't have constructors for these classes because if I were to have to provide all the atomic information that I need in order to have a fully fledged first citizen curve object or BRep, because they are NURBS geometry, the properties that they need, all the control points, all the NOT information, the domain, all of that, it's very tedious and mathematically intense to generate. And not very honestly, it escapes my own personal comprehension to how to do that in many cases, right? So, and the same for BReps. We cannot generate all those numerical representations manually. As opposed to that, we're actually used by using Rhino, we're used to other methods of creating curves and creating BReps, which is by using third-party information or using methods of modeling that lead to the creation of these objects. So for example, I can create a curve by interpolating through a sequence of 10 points. Turns out that the math behind that operation is kind of complex, so it is a little hidden behind the scenes inside of the RhinoCommon geometry kernel. Same for BReps. If I want to create a BRep as a loft between a series of curves, the math behind that it's pretty intense, and doing that manually ourselves, if we knew how to do that, then basically Rhino as a modeler would not have a lot of commercial value, right? So that's why all of that goodness is hidden away from us. But Rhino gives us interfaces, methods, and ways to generate BReps and curves from those types of source information. So particularly, what I would like to teach you in this video is the 2 main patterns that are a little specific to Rhino and which are used to create these types of more complex information. And the first pattern that I'm going to describe to you is what's typically referred to as the factory method in the C# programming language. What that means is that the factory method pattern is a design pattern that is used very often for the creation of new instances of objects, but instead of using a constructor, the factory method typically uses what's called a static method in the class. Let's take a look at what that means. What that means is that, for example, let me create a new file, and let's say that I want to create the folder, the component, which is going to be blend curve. Okay? There is a component that takes two curves and that blends them together. That creates a third curve that is the blend between the two with a particular continuity. And let me actually put here a little bit of data. For example, this one here, right? And these are going to be the two curves. So I'm going to take one curve as an input. Then this is going to be the other curve as an input. And then I'm going to plug these two together. All right. And you can see that the component has generated this interpolated curve that is blended and it maintains curvature and tangency at the two ends. All right. So here, for example, I have this slider that I can use to control the type of curvature. 2 means the type of tangency, the continuity. 2 type means curvature, 1 means just tangency, and 0 means position, which ends up being just a straight line. Okay? So how could we generate this curve using RhinoCommon? Well, if I go to the curve class, you can see that the constructor, there's no constructor with two curves and an integer for the continuity. We don't have such a thing. However, if we scroll down all the way to the methods, we will see that at some point we reach a section that has a lot of methods that are called create arc blend, create blend curve, blend with continuity, create Boolean difference, create Boolean intersection, create curve 2B, create fillet, create curves, create matching curves, create text outlines, create twin curves. There's a lot of methods that are useful for creating curves, all right? And each one of them, depending on how they create these curves, they use different inputs. So this one takes two curves, this one takes, for example, a list of curves, this takes a list of curves and a plane, etc., etc. Okay? Now, what I want you to notice is that all of these methods have this S icon here on the documentation. So for example, if I click on create blend curve, I can see that in the documentation, this tells me that I can create a curve blending between two existing curves. And the documentation tells me that given a curve, given another curve, and given this other thing called blend continuity, which I will explain in a second, the returning type is going to be a third curve. So this is matching where I am. So I kind of like this. It's just that there is an additional thing that I need to keep in mind, which is that this method is static. And this is the difference, and this is where the pattern kicks in. The idea is that Rhino uses static methods for the creation of more complex geometry. And what does that mean? It means that instead of using constructors where I pass this information, it designs particular methods, but these methods do not belong to instances of classes. Sorry, for example, they do not belong to instances of particular curves. I cannot create the blend curve calling it on curve A or curve B or any particular curve. The only way I can call this method is because it is static, I need to call it from the class itself. So the class itself, the overall class, will have these methods which do not belong to any particular curve. They belong to the class in itself. And the only difference is that the syntax will be a little different. instead of typing a dot create blend curve, I will type curve, which is the name of the class, dot, and create blend curve. I know that this is a little bit confusing, but let me show you an example of that. So I'm going to try to replicate this component. I'm going to say the input is going to be A, this other input is going to be B, and then and this is going to be of the type curve, which I'm kind of hiding here, and B is going to be of the type curve, okay? And then this is going to be the blend, for example. And I'm going to input this curve here, I'm going to input this other curve, and I'm going to turn this off to see if things work out. Now I am going to double click here. I'm going to have my development here. And then what I would like to do now is I'm going to design the algorithm and I'm going to design the outputs. So the algorithm is going to be that I want to create one curve that is the blend between the other two. So I'm going to create a curve that I'm going to call blend. And here, maybe before I would have been tempted to say new curve from A to B and with 2 as continuity, right? But if I do this, this doesn't work because the geometry curve class does not contain any constructor that takes these arguments, okay? Remember, the curve class, does not have those constructors. Instead, what it has is the whole create blend curve method. So maybe I may feel inclined to say, okay, well, instead of this, if there's no constructor, then maybe what I need to do is I need to say a dot create blend curve and then a b, but this also does not work, okay? And it doesn't work because create blend curve does not belong to any particular curve or A or B, it belongs to the class. So the correct way of calling static methods is by calling them from the class itself. So what that means is that I can type curve, which is the name of the class, dot, and as I type dot, you can see that right away I start getting access to a lot of those static methods, okay? A lot of those static methods that give me additional functionality that doesn't belong to any particular object. So for example, I can choose create blend curve. You can see that it's static here, that it takes 2 curves and a blend continuity object, okay? So I'm going to do blend, create blend curve, all right? And then the inputs are going to be A, then it's going to be B, and then it's going to be an enumerator that describes what position, what tangency do I want between them. So for example, I'm going to scroll down and say that I want tangency continuity. And if that's the case, then the output blend should be equal to, I want to output on the component this variable that I just created. And if I do that, now things work out. And then you can see that as I click here, this nice curve is getting highlighted. And you can see that it's not exactly the same as the one we have in here because I chose tangency, which is number 1. Okay, so if I were to choose here, if I were to choose blend continuity dot curvature, then I would be equal to option number 2 here. Okay, so that I just described, this idea that you can create new objects of a particular type by using methods that are static and that don't belong to any class and to any object, but belong to the class itself. This idea is what's typically referred to as the factory method pattern. And I'm explaining this here in this video because it's a pattern that is extremely common, in particular inside of RhinoCommon. All right? RhinoCommon, common, right? So here we are, and that's the reason why I'm going to explain this. Okay, so let's see another example of using factory methods to construct new instances of objects here in RhinoCommon. So we have seen how to do it with curves, but here I have another example where I have created a BRep, a surface, out of 4 points that I am loading in from Rhino. So you can see I can move these points that are in Rhino and are referencing Grasshopper, and then I can create a BRep from the 4 corners. Okay. Now, how could I do that? Well, if I were to write, and here I have an empty C# script component where I have plugged in the 4 inputs, I have renamed the inputs, I have renamed the outputs, and I have made sure to right click and set that the input type for each one of them is point 3D. So once I have this, now the question is, how can I create inside here in the code, how can I create a BRep just working with 4 points? We have the same problem that we had here before with curves, and is that if we go to the documentation, which is typically the first place where we should start, if we go to the documentation, we can see that we don't have constructors with 4 points or with curves or whatever. What we know is that if we keep scrolling, if we go to the properties, we can see all the different information that we can retrieve from BReps. We can see that we have a lot of methods that are part of BReps, and in general, you can see that this icon, the purple box, signifies that a method is an instance method, which means that it belongs to particular objects. So I can call it from a particular BRep. However, the ones that have the big S are static methods. And those are the ones that can be accessed from the class. So if I keep going down, you can see that at some point I reach this create section where there's a lot of methods that are called create something. Create baseball sphere, create Boolean difference, create Boolean union, create transfer, contour, fillet, create from box, create from cylinder, from loft. We're going to use this later in the example. From sphere, from sweep. There's a lot of different methods, and the list keeps going on and on and on. Because Rhino gives us a lot of really interesting methods to create BReps. And you can see that invariably, all of these are static. They all have the tiny s. So what that means is that they're all called directly from the class. And in this case, for our example, for example, I think that the create from corner points is going to be particularly useful. So I'm going to click here and I'm going to read the documentation and notice how this is pretty much what I expected. I have a method. The method takes 4 points as inputs. It takes an additional argument, which is the tolerance. It returns a BRep. So that's what we get in result. And the method is static, which means that we don't call it directly from any BRep, or it's also not a constructor. We call it from the BRep class itself. Let's go and take a look at how this works. So yeah, I am back in Grasshopper. And then here, what I say is I'm going to create a BRep that I'm going to call surface. And this is going to be not a new BRep that I pass A, B, and C. No, because this is the constructor way. So we have seen how the way this works in Rhino is that we use the factory method. So that means we call the class BRep. That's the name of the class. We use dot, and then you can see how immediately we get all this autocomplete with the different factory methods that we can access, the static methods that are part of the BRep class. I can keep scrolling, and you can see that I reach at some point create from corner points, which is what I want it to be. And so I do that, and then here I can say A, B, C, and D, and then you can see that the 5th input is going to be some kind of tolerance. We have not seen yet how to get tolerance from the document that we're using, so I'm just going to type some small value, okay? All right, and then once we have that, we say the output S of the component has to be the value of the variable surface. And when we do that, I should be able to hit OK. And you can see that this is very dark red, and that's because the two surfaces, the vanilla one and the C# one, are overlapping with each other, which is a very good sign. It means we did a good job. All right. Beautiful. So what's the bottom line? First thing that I want to teach you in this video, whenever you want to create curves and BReps and meshes and complex data objects, the very likely when you go to the documentation, don't look at the constructor. That's not how we typically do them in RhinoCommon. You typically need to go into the methods section and look for static methods to create these data types. All right. And also very helpful for you is to be able to see what kind of processes you can use to generate BReps. Just read the documentation, read the names of the methods, read their descriptions, and it will give you a really good idea about the options that you have for creating surfaces. Okay. And also a friendly reminder, in our other playlist, the Learning C# playlist, there is an episode where we discuss static members and we discuss how to create classes that have instance members, static members, the difference between them. So if you want to hear about this topic again, make sure to go and check out this video. A card should be popping somewhere up there, or maybe the link is in the description. We will see about that. All right. Wonderful. And with this was the first pattern that I wanted to teach you. In the second one that I want to teach you in this video is going to be the out modifier in input parameters. Okay, so for example, let's take a look at other types of geometrical operations that we might often do. And let's take a look particularly at the kind that when executed, they deal with a lot of information and they want to give us back a lot of different information and in different types. So for example, let's say that we want to, for the surface that we created before, that we wanted to compute the intersection of that surface with a plane in three-dimensional space. So what I have done here is that to the surface that we had before, I have dropped this component that is called intersection between a BRep and a plane, all right? Or otherwise called a section. And then I have fed the original BRep, I have fed it a horizontal plane that is controlled by a central point. So if I move the point a little bit up or down, you can see that where those intersections are happening is changing, all right? And another thing that is worthy of noticing here is that the output of this component is two different things. One, it's a family of curves, but at the same time, it has another input, which is a set of section points. There are certain instances where, depending on the geometry of the BRep and the geometry of the plane, the intersection may actually be just one point, all right, instead of curves. So this is something that we have to take into account or into consideration. So I have created here a C# script component that has symmetry with the vanilla one. So the input is B, the other input is P for the plane. I haven't typed them, so I'm going to right click here and set that this one needs to be of the type BRep, which is right over here, and P needs to be of the type plane, which is right over here. Okay, and then I'm going to feed it the BRep, I'm going to feed it the plane, and I'm going to plug in here a couple panels. So this panel here, and then this other panel here for the points, and then I'm going to copy these two here, and I'm going to do it here and here. Okay, so right now we are ready to write our algorithm to generate the solutions and another section for the outputs of this component. Okay, so we want to create an intersection between a BRep and a plane. Where do we even start? What is that in RhinoCommon? Well, turns out that intersections are a little weird in Rhino. For some reason, they are not part of the geometry namespace. They are in a different namespace. So they're actually in a They're actually in a different namespace that is inside of geometry, which is called intersect. Okay, so if I go here to Rhino Geometry Intersect, you can see that intersect has a bunch of classes, structures, enumerators, etc. to generate static intersections. And then intersection is a class that provides static methods for the computation of intersections. We've already seen that before, what that means. This is just a big class that the only thing that it does is it has static methods to generate these kinds of intersections. And we can see that there is one among the first one, which is BRep and a plane. So it intersects a BRep with an infinite plane. If I click here, I can see that this is starting to look familiar. So BRep plane, the input is a BRep, it's a plane, there is a tolerance, and it is a static method that returns a Boolean type. It doesn't return curves or it doesn't return points, which is kind of strange, correct? Now, the problem here is threefold. The problem is that this method is actually quite nicely designed because it is able to give us back the curves, the points, and a Boolean flag that tells us if the intersection succeeded or not. The plane might be somewhere away that doesn't intersect the BRep at all, and then the result might be false. And this is very good to know if we want to do conditionals like, oh, if the intersection worked out, do something. If it didn't, give an error, warning, etc., etc. So that is very nicely. The problem is that in C#, when you create functions, functions can only return one data type. So they can only return a Boolean, or they can only return an array of curves, or they can only return an array of point 3Ds. And that's it. They cannot return three different things. That's just not part of how the language works. So what is a workaround to do to this situation in situations where a method wants to return a lot of different things? The workaround to this is another pattern that RhinoCommon in particular uses a lot, which is using out modifiers for certain input parameters. What does that mean? It means that before we call this BRep method, what we do is we generate variables, empty variables, that are going to be containers for the information that we want to retrieve back from the method. And then what we do is, when we call the BRep plane, as part of the arguments, we also pass in those variables that we just created, which are empty, they have nothing, because what we want is for the method to fill them in with the intersection curves or with the intersection point or with whatever information we want to get back. And what's interesting about this method, this pattern, is that we don't have any limit about how much empty containers we can provide to a function to get filled in with data. And we also have no limitations about the types of them, because this can be an array of curves, this can be an array of point 3Ds, and the method can still return something. It can still return true or false, in this case, for example. So that's why this idea of modifying some of the inputs to have this out modifier to indicate that this is not information that the method needs in order to work with it. What this input is basically a handoff of an empty container to be filled in with information by the method and to be then sent back to whoever gave it to the method. Does that make sense? Maybe it doesn't, and that's fine because it's a really strange way of explaining this. But let me show you an example of how to do this. So we said that we're going to call the BRep method, which is static, and it lives inside Rhino geometry intersect. So because this is a very okay. So I'm going to write it here. So we're going to start by saying we're going to find that method. So I'm going to start typing Rhino dot, and you can see that I find the geometry namespace dot intersection. You can see intersect, and then dot, and then intersection is the class that contains all those methods. If you ask me, I find that all of this is a little strange. I don't know why the intersection is just not in geometry, and that's it. But it is what it is. And then when I hit dot, you can see that I get access to all the static intersection methods. And I get here this one called BRep and plain. All right. So BRep and plain is asking me for a bunch of things. It's asking me for the BRep that I want to use, that I want to cut. So that's going to be B, the input. The plain that I want to cut with, that's going to be P. A value of a tolerance, and for the time being, we're going to use just a small number, all right? And then it's asking me for the out parameters. It's asking me for a empty container to store the section curves, and another empty container to store the intersection points. How can I do that? Well, a way to do this typically is to do that beforehand. So what we can do is we can say, I'm going to need an array of curves to store those intersections. So I'm going to create an array of curves, right? And I'm going to call this sections. I'm also going to need an array of points, which are going to be the intersection points. So I'm going to create here a new variable, which is going to be an array of point 3Ds, and I'm going to call this intersects. Okay? And then, once I have those empty containers that have absolutely nothing, those are the ones that I pass to the method. I'm going to hand off my sections variable, which will get filled in with data, and I'm going to pass in my intersects variable, which will also get passed in with data. All right? And hopefully this will work. So whenever this method gets called, this is the input data, this variable gets filled in with data, this variable gets filled in with data, and now we can use that to output the results. So the output C should get the result, whatever is stored inside of sections. And remember, I can output arrays. That's not a problem at all. And the output PTS should have whatever is now available inside of intersects. Correct? Let's see if this runs. Boom! I got an error here. So what is the error? The error is that, that I do this all the time. Let's take a look at the error. The error is the argument 4 must be passed with the out keyword, and the same for argument 5. This happens to me all the time. So what I need to remember is that this needs to explicitly have an out modifier that I pass in here, because otherwise the component gets confused. It thinks that it's actually information that it needs. All right, so I'm going to hit run, and then I hope that this works now, and I can see that I have two planar curves, and I can see that these two planar curves are overlapping with these ones here. So you can see if I turn them off, everything gets turned off, and these are the intersections. So it looks like it's working well. All right, this is great. Okay, this is working pretty neatly. I'm going to plug in something here to the out component, because something that I want to highlight is that this is working great, but this is not very elegant, because if you remember, the BRep method also gives me a return type, which is of the type Boolean, which tells me whether if the intersection succeeded or not. So what I can do is that this is actually really important information. But in my case, in my code, I have not dealt with that at all. There's no way I am reading or I'm using that information that is coming back from the BRep plain method. So something that I can do is I can say, let me create a Boolean variable that is going to be called success, and it's going to be whatever this method returns, that Boolean that it returns. Remember, these two have their own way of working, so they get filled in whatever, but the return type is a Boolean value. And then here, what I can do is I can say, if success equals true, or we can shorthand this to success, then we can print on the console intersection worked. And then otherwise else we can print intersection failed. All right, and let's see if this works. So I'm going to hit OK, and you can see that right now intersection worked, and I have the point, so I'm going to start moving it up a little bit, up a little bit, up more, up more, up more, and all the way until I leave the surface. And at that point, you can see that the intersection still worked, but it just has nothing on it. Okay, it's just giving me no intersection whatsoever. And this one is actually, and this one is now failing here. All right, this one is failing, and this one is failing. Wow, that's pretty nice. So we are catching the same errors here. All right. Neat. All right. I like this a lot. Okay. So this was great. Remember the out parameter and the idea that we may need to use some methods where we need to predefine variables that will get completed with values that are generated inside of the function and that are referenced with the out modifier. This is a very common pattern that we will find in Rhino, specifically when we use methods that deal with a lot of information or don't want to give us back a lot of information. The intersection ones are a typical example. Subdivision components are also a very typical example. All right. If you want to learn more about the out parameter, you have the Microsoft documentation, but also here in our Learning C# playlist, I have an episode as well where we discuss out parameters in function arguments, and you can learn a bit more about that, technically what that means. All right. Oh, look at me. It's this guy here. Boop, 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 boop. I poke your nose, poke your nose. Okay, so that was advanced geometry types inside of Grasshopper. And I think what I'm going to do next is that the next video is going to be another hands-on exercise where I'm going to go over more examples of factory methods. So creating lofts, creating sweeps, creating interpolated curves. And I'm going to do more of this other example, using methods that require inputs with the out modifier. Okay, so let's keep building up our plugin with some nurse geometry components using all these techniques. Okay, thank you very much. If you like this video, maybe hit the like button or subscribe to the channel, or just say hi in the comments. That's also fine. And see you on the next video. Thanks a lot. Bye bye.